Good evening, class. We are in Chapter 4, Section 2, finally. And what we're going to be focusing on today is what congruence is to any shape and also to triangles. To start with, the first concept that we will be dealing with will be number 4. Just what are congruent figures and their corresponding parts? First of all, we know congruent means same size, same shape. And this part that means figures is a two-dimensional shape. So if I'm saying congruent figures, that means two shapes that are the same exact size. That means every single part will be the same. For instance, down here, all parts of one congruent figure are congruent to the corresponding parts of the other. So for instance, if I say segment AB here is congruent to segment FG, and segment BC is congruent to segment GH, that means the angle between them, angle B and angle G, also have to be congruent. The corresponding part, the part that matches up. If I look here, this is how I say these two shapes are congruent. I read this one as pentagon ABCDE. Pentagon ABCDE is congruent to pentagon FGHJK. This is called a congruent statement. If I'm looking for it, I'm asking you to say which two shapes are congruent. Still the same figure, but now let's actually name the corresponding parts that are congruent. If I look here, angle A and angle F have to be congruent because of the first letter in my statement. Angle B and angle G have to be congruent because they're the second letter. Angle C, angle H have to be congruent because they're the third. And here we go. Because of how it's ordered, this is how I would mark my diagram, and this would also be how I would say it. Angle A and angle F are both the first letter, so they have to be congruent. Angle B and angle G are the second letter, so they have to be congruent. Just to give you an example, this is where I got these two. Angle D and angle J are congruent because they're the fourth letter in my congruent statement. Also, I realize this isn't the normal way that I usually mark these congruent, but this is a way to mark that this angle here is congruent to this one. But angle E and angle K are congruent to each other, but not angle F or angle D. Again, I'll say that. Angle E and angle K are congruent to each other, but because they have a different number of tallies, they are not congruent to angle F or angle J or angle D or any of the other angles. They're just congruent to each other. Now here's the thing. If I want to say statements are congruent, they have to be in the same corresponding location again. So for instance, if I say segment AB, then I would also choose the first letters over here. Segment FG are congruent to each other. Similarly, segment BC, these two letters, the second and the third, would be congruent to segment GH. If I look at the picture, segment AB is congruent to segment FG. Yeah, they have to be, because they're both between the corresponding angles marked. Segment BC and segment GH also have to be, again, they're between the same correspondingly marked angles. So if we look, those are all the ones that match up. The one big exception to this is the first and last letter are also ones I can choose. So segment AE would be congruent to segment FK. From there, the letters will always be next to each other. Segment DE to segment JK or KJ, segment DC to segment JH, segment CB and segment HG are congruent, and segment AB and segment FG are congruent. That's it. That's how you can identify congruent figures and their corresponding parts. This here is the congruent statement, and it's lined up such that the first letter and the first letter here match up perfectly. They're corresponding. Angle A is congruent to angle F because they're both the first letter. Segment AB is congruent to segment FG because they're both the first two letters. That's how I would label congruent figures, and that's how I would label their corresponding parts. And again, just to show you, I chose AB and FG here, and that's how I chose these ones all the way at the bottom. Alright, this here, I'm just doing it for triangles now. I've turned one of them. I've told you two of the triangles are congruent from the congruent statement over here. triangle ABC and triangle DEF are congruent. So that means angle A and angle D are congruent. Now they're both not on top of the triangle, but they are both the same type of angle. These are both identical. It can be a rotated figure, but now it's in a different corresponding location, so to say. Angle E here, because it's the second letter, matches up to angle B. They're congruent. And the side between both of those angles, segment AB and segment DE, also are congruent. So it matches up. This segment is congruent to this one. This segment here is congruent to this one here. And this one is congruent to this one. And those are the angles. Again, I said angle A is congruent to angle D, angle E is congruent to angle B, and angle C is congruent to angle F. And here's just it written out in 4 words, or 4 letters. I didn't actually need the picture here to say this down here. For example 1, I ask you to write a congruent statement for the triangles and identify all pairs of corresponding congruent parts. Go ahead and try that real quickly. Now, the first part I would do is a congruent statement. If I look, angle M here is 1, angle Q is 1. So, angle N is 2, angle R is 2. So if I started triangle MNP, I could then say triangle QRS. The way that I chose to do it here was that way, from the 1 marking to the 2 to the 3 for the points. Same thing here, from the 1 marking for the angle to the 2 marking for the angle to the 3 marking for S. Corresponding order matters a lot. The next part I believe I did was sides. I then said, well, segment MN and segment QR have to be congruent. Segment NP and segment RS and segment MP and segment SQ all have to be congruent to each other, like such. And then the last thing, I would say angle M is congruent to angle Q, angle N is congruent to angle R, and angle P is congruent to angle S. And there's example 1. Hopefully you did it correctly. If you didn't, you might want to restudy the section or ask me questions. The next concept is what we call the third angles theorem. I'm guessing we're talking about a third angle somewhere, and this is actually only specific to triangles. If you try applying this theorem to something other than triangles, wrong. Third angles theorem. If 2 angles of one triangle are congruent to 2 angles in another triangle, then the third angles are also congruent. So in this case, angle B, angle E are congruent. They're both right angles. Angle A and angle D are congruent because they're marked. So therefore, angle C and angle F have to be the exact same angle. And that's all that this third angle says. If I have 2 matching up to 2, the third ones have to be congruent. Alright, let's do an example. Find the value of x. So for the first one here, what I'm looking at is this angle matches up to this angle. This 50 matches up to this 50. So this here is technically my third angle, 3x and x plus 30. And because I just know the third angle, I have 2 angles being congruent to 2 angles in another triangle, the third angles are also congruent. So that means this measure here, 3x, has to be the same as this measure, x plus 30. So I now applied my rule right there, and at this point it's just a simple problem of solving for x. Subtract x from both sides. I get 2x equals 30. Divide both sides by 2, and I get x equals 15. And because all they were asking for was finding the value of x, I am done. If they were asking me to find a missing angle measure, I would have plugged it back in. It's not a bad idea to just plug it in to double check. If you do, 3 times 15 is 45. 15 plus 30 is 45. It works. 2. I have a right angle in the bottom left, and I have a congruent angle in the upper right. So that means the angle in the bottom right also have to be congruent by the third angle theorem. So I have 2x for one of the angles, 50 for the other one. So that means I set them equal. 2x equals 50. Divide both sides by 2. I get x to be 25. So if we look at that picture, again, I see that this angle here, 2x, has to be the same as this angle here, 50. Because the two other angles in the diagram are congruent, the third one also has to be. The next one is something that we've done over and over and over again. So I'm hoping that you know it at this point. I'm just letting you know that it works for triangles too. This is the sixth concept of chapter 4. The reflexive, symmetric, and transitive property works for triangles. If I have a triangle ABC, it's of course going to be congruent to itself. It's like a mirror. So for any triangle, triangle ABC is congruent to triangle ABC. The symmetric property, triangle ABC is congruent to triangle DEF. Well, it doesn't matter then if I would switch it around and say triangle DEF is congruent to triangle ABC. Symmetric is where it's flipped. The same one way as the other. And then the transitive property is getting rid of that middle person. It's the dominoes falling. If triangle ABC is congruent to triangle DEF, which is also in turn congruent to triangle GHI, well then the two on the ends have to be congruent to each other. Triangle ABC is congruent to triangle GHI. Two triangles congruent to the same triangle are congruent to each other. Let's just see if you can apply these rules. Alright, so here's the three things. Name the property illustrated. If I have triangle ABC congruent to triangle GHI, and I have triangle GHI congruent to triangle ABC, well, that's flipping it around this way. Symmetric property. The next one, triangle CBA is congruent to triangle HIF. And I also know that triangle HIF is congruent to triangle TOR. Therefore, I'm saying this triangle, CBA, is congruent to this triangle, TOR. Yeah, that's definitely the transitive property. And if I have triangle DEF congruent to itself, it's like a reflection, although it's spelled differently, we call it reflexive. Alright, that's concept number 6.